All right, so I figure I'm going to knock out formula mass and percent composition all at the same time because the two processes blend so smoothly into one another. So let's start with formula mass. Formula mass is the number of moles or number of grams you would need to have 1 mole of a compound. Formula mass is the number of grams that you need to have 1 mole of a compound. To figure out a formula mass, what you're going to have to do is break a chemical formula down into elements, the number of atoms of each element. Break the formula down to the number of atoms of each element. Multiply the number of atoms by the atomic mass from the periodic table. And these atomic masses are also referred to as molar masses. The atomic mass tells you how many grams of that element that you would need to have 1 mole. So these atomic masses are called molar masses. So you might say multiply the number of atoms by the molar mass. It means the same thing. You'll add all your totals together. And that will give you your formula mass for that particular compound. So let's take a look at magnesium nitrate. If we're doing magnesium nitrate, the first thing we have to do is break it down to the number of atoms of each element. So for magnesium, there'd be 1. There's no subscript on the magnesium, so we assume it's 1. For the nitrogen, it's what's on the inside times what's on the outside. There's nothing there next to the nitrogen, so we assume it's 1. 1 times 2 gives us 2 nitrogens. And then for the oxygen, it's 3 times 2. What's on the inside times what's on the outside. We'll multiply those number of atoms by the atomic mass or the molar mass of each element. So magnesium, straight from the periodic table, 24.31. Nitrogen, straight from the periodic table, 14.01, and oxygen, 16.00. So that's 24.31. That's 28.02, and that is 96. And again, these are the masses straight off the periodic table. So for oxygen, I'm looking right here. That's where my 16.00 came from. That's the atomic mass or molar mass of oxygen. There's nitrogen's, the 14.01. Comes straight off the periodic table. That's the atomic mass or the molar mass of nitrogen. I add these 3 things together. That's my final step. So 96 plus 28.02 plus 24.31. That is 148.33. Double check that just to make sure. 96 plus 28.02 plus 24.31. Yep, 148.33. All right, at this point we can say 1 mole of magnesium nitrate equals 148.33 grams of it. That's an equivalence that we're going to eventually be using in our mole mass conversions. Now, let's move on to the computation of percent composition. It's a percent. And percent, generally speaking, is part divided by whole times 100. That's how you figure out a percent. Doesn't matter what it is. So if we're talking about your test grade, you figure out the part that you got right divided by the total number of questions times 100. And that's where your average on the test comes from. That's where your percent on the test comes from. We're doing the same thing here. So our part is going to be that individual element's contribution. So this is the number of atoms times the molar mass. And again, molar mass and atomic mass are the same thing. It's just that number off the periodic table. That's our part. The number of atoms of that element times its molar mass or atomic mass. The whole is the formula mass for that particular compound. So let's work this out for the one that we just did. So for magnesium nitrate, we had this. The magnesium was 1 times 24.31. The nitrogen was 2 times 14.01. And the oxygen was 6 times 16. And that added up to 148.33. So now, if I want to do the percent composition of the magnesium, I would take this right here, because that's magnesium's part. 1 times 24.31. And this is percent magnesium. That's magnesium's part divided by the whole times 100. Or 24.31 divided by 148.33 equals times 100. And rounding to a whole number percent, that would be 16%. So the percent magnesium is 16%. If I wanted to do the percent nitrogen, again, it's nitrogen's part, which is 2 times 14.01 over the whole, 148.33 times 100, or 28.02 divided by 148.33 times 100. Rounded to a whole number percent, that would be 19%. You would do oxygens the same way. It'd be 6 times 16, or 96, divided by 148.33 over 100. A way that you can self-check yourself on these is to add up all your percents when you're done. Go ahead and calculate every percent for every element, and then add those up. If you did it correctly, they should add up to 100.